Every time an engine runs, anywhere on Earth, this is the part making it possible. And almost nobody knows how it's made. Inside every engine block on the planet, one component converts raw explosion into rotational power. It is called the crankshaft. This bar of steel weighs 110 kilograms. It is forging-grade carbon alloy. Right now it is cold, rough, and completely unrecognizable. And this is what that same bar of steel looks like after the forge is finished with it. This is where we are going. He has forged crankshafts for 30 years. He knows exactly what is going to happen to that billet. 10,000 tons of pressing force. Standing 12 meters tall. This machine is about to reshape steel at a molecular level. Before the press touches anything, the steel must reach exactly 1,250 degrees Celsius. This furnace will get it there in 4 minutes. Inside the induction furnace, the steel goes from black to orange to white in front of your eyes. The molecules are reorganizing. 1,247 degrees. Not 1,200. Not 1,300. This specific temperature. Because plasticity in high-carbon steel is not a range, it is a number. The billet is now a white-orange mass moving at controlled speed toward the first press. It has maybe 4 minutes before it cools too far. 300 bar of pressurized water fires from every direction. 2 seconds. The scale is gone. The steel surface is clean and ready. The robot arm does not hesitate. It does not drop. It grips the 1,250-degree billet and moves it with precision that no human hand could hold. The roughing die is a blunt approximation. Its job is not precision. Its job is to move 110 kilograms of steel into a general crankshaft direction. 10,000 tons. This is the number. Enough force to flatten a small building in one stroke. And it is about to meet the billet. The ground shakes. Everyone within 50 meters feels it. And from the explosion of scale, the first rough crankshaft form is born. The rough shape is not impressive yet. But look closely. Those offset positions, those are the throws. The crankshaft is already inside the steel. 3 dies, 3 blows, each one closer to the final form. Each one leaving less room for the steel to go anywhere except the right place. The piece is moved between die sets while it is still hot enough to form. Timing is everything. Every second of delay costs temperature. Second blow. The throws are now clearly visible. The counterweights are forming. The crankshaft is starting to look like itself. Third blow. Now, without any question, what you are looking at is a crankshaft. The forge has done its primary work. A forge worker reading hot steel through tongs is not guesswork. It is 30 years of calibrated judgment that no instrument replaces. The finishing die is the most expensive tool in this building. Machined to within 2 millimeters, used for thousands of strikes before replacement. Maximum force. One final blow. This time the steel has nowhere to go except into the exact geometry of a crankshaft. No excess. No compromise. There it is. Still glowing orange. Still surrounded by flash. But for the first time, a complete forged crankshaft form exists in this world. The flash ring is waste material, the thin steel disc that spills from the die parting line. One press stroke removes it permanently. 3 crankshafts in sequence. The first still orange, the second cherry red, the third near black. You are watching steel transform on the cooling rack. Back into the furnace. This second heat cycle is not to soften, it is to normalize. To relieve the stress that forging introduced into the grain. The quench is violent by design. The temperature drop happens faster than the steel wants to cool. That violence locks in hardness. Shot blasting removes every trace of forged scale. What emerges is not shiny, it is clean matte gray. The real steel, finally visible. The straightening press is the most understated operation in the building. 0.3 millimeters correction. Barely a movement. But without it, vibration destroys the engine. The CNC lathe removes material in controlled violence. long steel chips spiraling from the cut, coolant flooding the zone, precision emerging from the chaos. Pin journal turning requires the tool to follow an offset eccentric path. It is orbital machining, and the motion looks like it should not work. The counterweights are not decorative. Their precise mass and position are what prevent a spinning crankshaft from destroying its own bearings at 6,000 revolutions per minute. 6 mm bore, 200 mm deep. The oil hole carries pressurized lubricant to the bearing surface. One blocked hole, engine failure. Multiple journals ground simultaneously. The CBN wheels are dressed to the exact journal profile. Every contact removes exactly the right material. The fillet rolling operation is invisible from the outside, but it doubles the fatigue life of every journal transition. This is why crankshafts last. Final grinding removes 0.05 millimeters, not 0.1 millimeters, not 0.08, 5/100ths, and the journal surface transforms from gray to chrome. The superfinishing stone oscillates 10,000 times per minute. The crosshatch pattern it creates will hold engine oil against 6,000 revolutions per minute journal rotation for decades. The CMM records 47 dimensions. Every one must fall within tolerance. One out-of-spec measurement, and the crankshaft does not leave this room. 0.0008 millimeters of roundness deviation on a surface rotating 100 times per second carrying 400 horsepower. That is what acceptable looks like here. Unbalance of 25 gram-centimeters sounds small. At 6,000 revolutions per minute, it becomes a destructive force that will destroy main bearings within weeks. The drill removes exactly enough mass to cancel the calculated unbalance. Not more, not less. This is balance mathematics in physical form. The polar diagram is empty. The crankshaft is balanced to within 1 gram-centimetre across its entire rotating mass. The machine confirms, pass. Magnetic particle inspection under UV light shows every surface crack larger than 0.1 millimeters as a bright fluorescent line. This one shows nothing. 58 HRC. Harder than most cutting tools. This surface will outlast the engine block it sits in, if the oil never fails. C8-2024-004471. That serial number is now permanent. This crankshaft has an identity. Every dimension ever measured is tied to this number forever. 47 dimensions. 47 green check marks. The inspector signs his name. The crankshaft is released. That signature means something real. The amber rust oil is the last thing to touch the crankshaft in this factory. After this, it belongs to the engine. The wooden crate is not ceremonial. These crankshafts travel thousands of miles. The crate is the last line of protection before the assembly line. The robot lowers the crankshaft into the engine block. Main cap bolts torqued to specification. The crankshaft is now part of an engine. First fire. The crankshaft begins to spin for the first time under combustion load. Everything that was made in that forge is now running. Inside that car at 120 kilometers per hour, the crankshaft we watched being made is spinning at 3,200 revolutions per minute, continuously, without interruption. Every piston, every connecting rod, every revolution of every engine, all of it depends on this one continuous steel component holding its geometry. 110 kilograms of rough black steel on the left, 35 kilograms of mirror-polished precision engineering on the right. Same material, completely different worlds. He made something real today. He does not need to explain what it is. He knows exactly what is inside every engine he drives past. The presses are still. The dies are cold. But somewhere on the road right now, a crankshaft that was forged in this building is running. Tomorrow morning, the shift starts again. Another billet is loaded. The furnace climbs to 1,250 degrees. And the process begins again from nothing. One oil droplet on one mirror journal surface, carrying the engine's entire rotating assembly. The crankshaft holds. It always holds. Every engine that ever ran, every car, every ship, every generator, every machine, they all needed this. They all still do. 110 kilograms of steel.